Okay, we're going to look at how we convert our on-site measurements onto our site plans. We're going to do offsets first and then we'll do trilateration afterwards. But let's just look back at when we measured up our site. You'll remember we had our baseline running along the two edges. You may have had it set up differently. You may have had it along the top edge and the other side edge, but that doesn't matter as long as you can convert that onto your paper. So what you'll need is your graph paper, a pencil, a set square, an eraser, a ruler, probably a sharpener, and the measurements you took during your offset survey. The first thing that we're going to do is recreate our baselines on the piece of paper that we're going to use. Now I use graph paper because I find it easier to use the measurements on the graph paper itself. So I don't always have to use the ruler. I know that these block sizes are 1 centimeter, so I can use that as a guide as well. Now our baselines ran along these two sides, so let's just draw those in. You'll be using A3 graph paper, so you can do the site at 1:1. If you were using this in real life, you would have to convert your measurements from whatever they were in the real world to a size that would fit onto your piece of paper. And you'd need to make sure that whatever scale you chose to do that would fit onto the graph paper or the site map that you are going to draw up. Luckily for us, it will fit onto the A3 graph paper, so we're going to use a 1:1 scale. Just to give you a little bit of background, what a scale means is converting real world measurements into a size that, as I said, fits onto the piece of paper. So we would represent, for example, on a bigger site, we may say that 10 centimeters in real life equals 1 centimeter on our graph paper. And we could do the conversion back again after that. We would say that every 1 centimeter, we could take measurements internally on our site. We would know that every 1 centimeter equals 10 centimeters in real life. And we could do, so that would be 1 to 10. We could do bigger sites when we're using meters, and we could convert it in the same way, in which case perhaps 1 centimeter equals 1 meter in real life. The scales may vary. It may be 1 to 200, maybe 1 to 300, but try to keep it at a round number because that'll make your calculations easier. So 1 centimeter on the page equals a meter or 2 meters or 3 meters rather than 1.5 or and so on. But for us, we are using 1:1. And as we go along, we will talk more about scale. You can have a look at the Facebook page and find out more about it there. The thing to know about the baselines is it doesn't matter how long the baseline is or how long the baseline was on our site. These measurements could go on to infinity. It doesn't matter. Although we only use this, that endpoint is, in our case, arbitrary. We record what the endpoint is, but it doesn't matter how long it is. And it doesn't matter how long we make it on the page. So because we had our baselines along each side like this, I'm just going to draw a line along the bottom and draw a line along the side. So this, remember, was baseline 1, and this was baseline 2. At the moment, it doesn't matter what that distance is. We'll convert it as we go. Now, because we know that these are 1 centimeter, we could fill this in already. We could, just for clarity, we could say 1, 2, 3, 4, 5, 6, 7, and so on. And the same going up. 1, 2, 3, 4, 5, 6, 7. It's handy to do that because it allows you to have a reference point for when you're converting your measurements from your site recording form onto the page. It just helps cut down on errors a little bit. So this is our 0 point going upwards on baseline 1 and upwards on baseline 2 to the left. Now we turn to the measurements that we took. And you'll remember for the offsets, we took 2 points on a cannon, which we called point 1 and 2, which were the back of the cannon and the front of the cannon respectively. So let's have a look and see what those measurements were. The first measurement was 16 centimeters along the baseline and 4.5 centimeters off of the baseline. So let's measure 16 centimeters. In this case, we could use the squares and count them along, but 16 centimeters takes us to there, and 4.5 centimeters from the baseline takes us to there. So that is our point. 16 centimeters along the baseline, 4.5 centimeters off of the baseline. So let's mark that as point 1. Next, let's look at point 2. We said that that was 20 centimeters along the baseline. So let's measure 20 centimeters. That takes us to there. And it was 5 centimeters from the baseline to the front of the cannon. So we can put a mark there. And we will number that 2. So if we connect those up, we will see that is the position and orientation of our cannon on the site in relation to the baselines. And we can do the same for all of the other objects that we have. And you will continue to do that with the objects that you decided to measure using offsets. Remember, it is helpful potentially to link up sites that are, or points that are linked, because that'll help you remember what the object is. It's helpful to number them because that'll allow you to refer back to your site recording form to know what the object is. If you would like, if the site is not too complicated and there's not going to be a lot of things around it, you could even label this Cannon 2, as we called it on our rec site. So that's how offset measurements work. And we'll have a look at trilateration in the next video.